Yeah, Tolo. Okay, let's move on. Improper integrals of second kind. These are those where we integrate over a discontinuity of f. Let me explain this on one example here. Integral from -1 to 2, 1 over x squared dx. Let's plot the function again. 1 over x squared looks like this and that. It's symmetric. But now we are integrating from -1 to 2. So we are interested in this area here under the curve. And of course, here the function goes to infinity. Okay, so there's a question mark. Not quite clear what to do here, where we have a vertical asymptote of the function. And whenever we have vertical asymptotes, or whenever we have to deal with infinity, we approximate with a limit. Same here, we split the integral at 0. We write the integral from -1 to 2 as an integral from -1 to 0, and then an integral from 0 to 2. And still the function is not defined as 0, so we still have to use limits. So then the upper limit 0 we replace by a limit b goes to 0 from the left. And the lower integration limit 0 we replace by a limit as a goes to 0 from the right. Basically the same idea as the improper integrals of first kind, where we took the limit as x goes to infinity. Now we take the limits as a and b go to 0 from the left or from the right. Let's compute the second integral on the previous page. So taking the limit allows us to use a definite integration. So I keep the limit. A goes to 0 from the right. And now the antiderivative of 1 over x squared is -1 over x, evaluated between a and 2. So we can do that quickly. Limit a goes to 0 from the right. Sub in the 2, then we get -1/2. And then minus is plus 1 over a. And now, as a goes to 0, this guy goes to infinity. Then the whole thing diverges to infinity. And we say that this improper integral diverges. Okay? So then the general principle is you find discontinuities of the function, and if it turns out the discontinuity is at one of the domain boundaries, okay, if you integrate from a to c, and the discontinuity is at c, then the upper integration limit is replaced by a limit. If it's for the lower integration limit, then you replace it also by a limit where you approach a to c from the right. And then if the singularity is between a and b, then you have to split the integral into two parts, where you have a left part from a to c and then a right part from c to b, where each part then again is replaced by a limit. Provided, again, that all these limits exist. Let me do one more example here, the integral from 0 to 1, 1 over root x. Let's plot 1 over root x. So now we are interested in this integration here from 0 to 1. We have a discontinuity at 0. So we need to replace the 0 integration with a limit. Limit a goes to 0 from the right, integral from a to 1, 1 over root x dx. And then this is equal to limit a goes to 0 from the right. Antiderivative is 2 root x, and then from a to 1 equals limit a to 0 from the right, 2 minus 2 root a. And now a goes to 0. Now we can safely let a go to 0. And everything here is equal to 2. Here we would say the improper integral converges and is equal to 2. You see, the method is not very difficult, but you need to know where the discontinuities are. You need to have a general understanding of the functions, and this is where, of course, calculus 1 comes to the play again, because we did this all in calculus 1. So then let me summarize the whole list of improper integrals of first kind and of second kind. But as I write them here all together, you will see, I hope, a general principle behind it, right? So in the first kind, we integrate to infinity, or from minus infinity, or in both directions to infinity. And we replace each of the infinities by the appropriate limit. If we go in both directions, then we have to introduce an intermediate point c and then split the integral into two bits. For the second kind, we handle infinity of the function itself through discontinuities, and again we split the integration into a left-sided and a right-sided limit, where the point of discontinuity is again approximated by a limit. So it's again the same idea. Now you could think of trying to remember all these 6 formulas, or what I would advise, you should remember one principle. And the one principle is, whenever there's trouble with infinity, you look at a limit.